So my name is Stevan Gavrilovic. I'm a postdoc at UC Berkeley at the SimCenter. And today I'm going to talk about the Regional Resilience Determination Tool, or the R2D tool. Quickly, before I get going, I'm just going to point out some web pages where you can go for more information. So this is the main web page. And there you got links to the documentation, where to download the app, and also links to the forum. And at the bottom here are two instructional videos, and these two highlight the GIS features in R2D. You can watch in your own time, and they also include how you can introduce or use your own custom fragility functions. So watch these two videos, they're fairly short, maybe half an hour each, and give you a better idea of what R2D can do. So I'm going to gloss over some things here. So just a general overview, provide some background for those of you who haven't seen R2D yet. R2D is essentially a combined simulation and geospatial processing tool geared towards assessing the resilience or the impact of natural hazards to urban regions. It's a multi-asset platform. We got buildings, and very soon, as we speak, I'm implementing lifelines such as gas networks and water distribution networks. And it's multi-assets that supports earthquake hazards, which is the focus of this group, but also hurricanes and tsunamis as well. You saw this slide previously, just to give you an idea where R2D fits into the general SimCenter framework. So we talked about EEUQ and QuoFem and how that fits into PBE, and then PBE kind of fits into R2D. So R2D is more or less the orchestrating app, if you will, that uses the hard work and effort that's been implemented in these apps below and zooms out to consider like a regional workflow type analysis. And you've seen this before too, and this is where R2D kind of spans all of these puzzle pieces. So from describing the assets to the hazards over a region, to how you can model those assets, to estimate damage and loss, and now finally we're working on simulating recovery. So all the way up to here is more or less done. And of course, we'd like new modules and new things to expand the workflow, but now we're shifting to recovery, kind of next long-term goal within R2D. R2D comes with pre-bundled with regional test beds and examples. So there's 10 now in total. For earthquakes, you'll see at the top row here, and these two at the bottom. And then we got a few hurricane examples, and I've just recently implemented a tsunami and regional site response example, which Quanchi and Pedro will be talking about next. I just want you to note that most of the examples are watered down test beds. Some are actually the entire test beds. But the idea is you can click on a button, download them into R2D, press run, and they should run right out of the box. It's very easy to get started. And today I'm going to be talking about the Alameda example, which is example number 5, which includes earthquake and liquefaction. And that's the one highlighted in right here at the bottom left. So without further ado, I'm going to switch to demonstrations, kind of just a general overview in slides, and I'll show you how R2D looks in real time. Okay, so if we could see R2D now. This is how R2D looks when you start it. This is your GIS pane that you see right here that you can manipulate with most GIS programs. R2D comes with QGIS built into it. And some of you may be familiar with that. So this is the main QGIS pane. On the left here, you have the layers. So as you import buildings, hazards, they will appear as different layers in this tree. And then finally, you have base maps where you can select a different type of base maps, whether you want to have the OpenStreet or satellite and that sort of thing. On the left here, which I will go through in detail once I load an example, but this left-hand ribbon allows you to select the different apps that are in the R2D workflow. And it basically follows the performance-based engineering methodology where you define the hazard, you define the assets, how they're modeled, what type of analysis methodology you want to use, and finally damage and loss, all the way to results. Also want to draw your attention up here to the main menu. The two important ones are the GIS map. So this is all the QGIS functionality that's built into R2D. You can access it from this menu item right here. And right to the next step is the examples menu. So I have a lot of examples already preloaded, but when you download R2D, this list will be empty. But you just click on Manage Examples, select the ones you want. And the reason they don't come prepackaged with R2D is they can be quite large. They have, say, a lot of ground motions and so on. Select the examples that you want. In this case, I want example 5, or all of them, or whatever. Click Update, and the examples will automatically be downloaded from the cloud, installed on your computer locally. And when you click on the examples menu again, it will just appear here, and you could click on them. So right now I'm going to click on example 5, ground shaking and liquefaction. You'll see it's loading down here. This is the program output panel of R2D. So when you run analysis, when you load things, this is where you see the output. And now I see loading done. That means it's loaded. And this is the Alameda, a city of Alameda here in the Bay, East Bay. And this is example 5. You'll notice that you'll see some building footprints here. I zoom in a little. And it's hard to see, but maybe if I turn this off, you'll see the ground motion grid, which are these little cross symbols here. And I'm going to turn these on again. And if I expand this building layer, you'll see there's 2 layers. There's selected buildings and then all buildings. So the selected buildings there are only the buildings that are going forward into the analysis. So if I want to run this on my personal computer, I don't want 14,000 buildings, which is how many there are in this example, to be running overnight. Maybe I just want a small subset, so I can select that small subset. I'll provide an example right now. So I'll click on the all buildings there, and then I'll click on the select button, and I could just drag this little rectangle, and everything within that rectangle will be highlighted yellow. Now if I click on Add Assets, and I turn off the all buildings there, now see that's added to the selected buildings there. So it allows you to pick the assets that you want and push it forward into the analysis. Which will bring me now to the asset definition pane. So I'll go here first. In this case, I'm loading a CSV file. So essentially all buildings.csv. And every building that I select will be here, the ID. So sorry, there's an ID for each building. Each row here corresponds to a separate building. And at a minimum, you'll have the ID, the latitude, the longitude, and then any number of building attributes, such as the number of stories, the structure type, and so on. But every building that I want to select for analysis, the ID should appear here. I'm just going to clear the selection. And if I go back here, now that selected building layer is empty. But I can go back here to asset definition and say input a range of buildings. Press enter, and just a total of 200 buildings are selected for analysis. If I go back here, here, there. So there's 2 different ways you can select buildings, either from the GIS pane here, or from the asset definition pane here. And if I add IDs here or select buildings here and vice versa, they will appear here. Going back to the Viz pane, you can also see the attributes for a particular building by clicking on Identify and then selecting the layer. So this select the building layer, and then when I click on a building, it'll pop up here. So it'll show you the building ID and then all the attributes for that building. I could just close that. And moving on, we got the general information pane, just to provide some general information about type of analysis you want to run, like the name, the units, and different output settings. We already went over the asset definition. Now we'll spend a little more time on hazard definition. So in this case, we have a grid. It's hard to see. Let me turn something else. So we have a grid of ground motions. If I click on Identify, you'll see at each point we get the PGA and PGD in the horizontal and vertical directions. So these are the intensity measures for each one of these grid points. And going back to hazard, you'll see I provide a CSV file with these grid points and a folder where I could find the ground motions, or in this case, it's in CSV files of intensity measures that correspond to the PGA, PGD, and PGV with the respective units. Now, there's other apps built into R2D, such as, say you don't have that grid and you want to create one on the fly. You can go to the earthquake scenario simulation app. And this is one that Quanchi created. And if I select create grid on a map, it will allow me to specify my own grid. So I can position this grid anywhere I want. Sit up here. I can click close, and then I fill in these other parameters, such as do I want to pull ground motions from Pier and GA West, or do I just want the intensity measures to be calculated at those points? And I click on Run Hazard Simulation, and at the end of the day, I should get, wherever I define my grid on the map, I will get this grid in a CSV file consisting of a grid, which I can later reuse. So I don't have to do that every time. I use the earthquake simulation tool. I create a grid of ground motion points, and then I could come back here and go to user specified ground motions, point it to that grid and load it. So that's how you can create your own grid. You could import the buildings as a CSV, as I show here, or also as a GIS file. So say you have a GIS file of building footprint, you can import your building inventory straight from your GIS file. You don't have to have it in a CSV format, such as this example. Moving on, this is the hazard to local asset event, so the hazard to asset pane. Here we define what type of mapping application are we going to use to map our building to the hazard, essentially the grid. So we have nearest neighbor here, or you can have site specified, where you use a grid point exactly over the site of your asset. But in this case, we have a sparser grid. And if we show our buildings, at each building, it will select its nearest neighbors. And here you define the number of sample and the number of neighbors. So that's essentially all you do in this pane. Moving on to the modeling pane. We only have intensity measures, and we're not going to use any type of finite element or building model. We're just going from intensity measures to damage and loss. So a building modeling application will be none, but other options could be OpenSeas or OpenSeas Pi type models. And then this leads us to the analysis engine. So again, you can use OpenSeas or OpenSeas Pi, but in this case, we have no model. We're just going from IM to loss. So we're treating our IM as our engineering demand parameter, or EDP. Finally, for this example, we use the Pelican damage and loss framework, and that has this MHEQIM method that's built into Pelican. And then we define other things such as the number of realizations, whether it's coupled analysis. And the special one in this example is down here, is to include ground failure. So here we also include damage from the ground shaking, but also liquefaction from ground failure. Moving on here, it's a UQ application pane. Here we have none. So in this example, we have no uncertain quantification and no random variables that you can edit yourself. And finally, when an example is run, this is where you see the results. So I'm going to do that now. I'm going to clear this, and I'm going to load the results from a small subset of buildings I ran a while ago. Once you have your results, you don't have to run it again. You could simply reload it, as I'm doing here. So here you see all the buildings again, and these ones in yellow are the buildings that I ran the analysis on. I'm going to go back here. First, so turning off the all buildings, now I see only the buildings that were included in the analysis, and you see they're graduated, or say classified according to color and according to their loss ratio. So the darker ones are higher loss ratios. And what I could do now is filter things. So using the QGIS capabilities, I could say right click on this layer, and I can go to filter, pop up on the screen, and then I can make these fancy filter expressions. So I could say, for example, my fields are listed here. Let's see if I can find, there we go. So loss ratio. greater than 0.25. And now I want to see how the older buildings perhaps are affected. And I click and then I go up to year built. So less than 1925. And if I go test, 0 rows. Okay, so nothing there. Let's try 19. 4 rows. So I have four buildings, the loss ratio greater of 0.25 and that are older than 1950. So if I click on OK, these are these buildings right here. And I can remove that filter. And pretty much, if you know SQL queries, you can make your own type of SQL filters to go through your results. And if you could also duplicate this layer. So if I go here and duplicate layer, and then I could play around with it, make massage the results. So I'll show you an example right now. If I right click and I go to open attribute table, it's going to show all my fields in a nice big table here. So what I can do is I could go up here and select open field calculator. And then I want to create a new field. So I'm going to create a field called coefficient of variation. And here I'm going to go down to fields and values. And I'll do the repair cost. So I'll do the repair cost standard deviation divided by the repair cost. And I'll maybe scale it by 2. And that's called, now that my output field name will be COV. I want it to be a decimal number. And if I click on OK, now at each row, it's going to calculate the coefficient of variation for the building. And close that. I could go back here and double click on it. And I'm going to change how things are visualized. So instead of a graduated, I'm going to go to single symbol. It's going to be simple fill. But instead of that, I'm going to do a centroid fill. And for the size of this thing, I'm going to select my field here, which I just created, called COV. And click on apply. Okay. And now you can visualize the uncertainty. So these bigger dots, if you will, are the ones with a higher COV, and the smaller dots have lower coefficient of variation in the repair cost results. I know this is a little quick, but at least it'll give you an idea of the type of things you can do within R2D in terms of post-processing once you have your results. And these filters, you can also use them to select buildings for analysis. I showed how I could filter buildings that I've already analyzed, but say you want to select buildings that are only concrete of a certain occupancy type. Well, you can do that here. Do that here, right click, filter, and then you do your filter and spread expressions such as occupancy class equals, and then I could hit sample and say, let's just pick res 1. Now I only have res 1 buildings. And when I click on select and I select a subset, it's only going to select buildings with the occupancy class res 1. So you can set up your analysis how you want it according to the attributes that you want without doing a lot of work using the QGIS pre-processing at this point. And I think that's it as far as my time goes, but I'll focus a little bit on the results pane. And when you run an analysis successfully, it'll say done, and then this pane will automatically pop up. And here it just provides kind of a general overview of your results, like the relative frequency of losses, a table showing a summary of the results. And yeah, I think I'll end it there. That's my time.